So today we are looking at Leetcode number 203, remove linked list elements. So here we have a linked list 1, 2, 3, 4, 5, 6. We want to remove all the 6s from that linked list and return the linked list. If the value is not in the linked list, we just go ahead and return whatever the linked list is. And if all the values in the linked list, or if there's duplicates, we want to remove all of those as well, as you can see in example 2 over here and example 3. Okay, so this can be a tricky question, and there's a pattern underlying this that that can make these types of questions a little bit easier. There can be some edge cases with linked list and removals and additions and deletions, and so using a trick that, which I'll go over here in a little bit, can really be helpful. Let's just kind of go over the conceptual overview, and then we'll kind of look at how we can use a pattern that can be helpful with this. So here we have 1, 2, 6, 3, 4, 5, 6. We have 1, 2, 6, 3, 4, 5, and 6. And what we want to do is remove the 6. Okay, so let's take a look at this. Let's say we only use one pointer. Okay, I'll just call this the current node. I'll use a different color. I'll call this the current node at 1. And our target value is going to be 6. So we can increment this current. Let's say we go current from 1 to 2, 2 to 6, and we check, okay, we hit 6. Now we have to remove this node. And unfortunately, there's no way to remove this node, because to remove a node, what we have to do is we have to take this previous node, the pointer there, and we have to move it to this 3. But if we are only using one pointer, we don't have access to the previous node. There's no way to access that previous node. And because of that, we can't just use one pointer. We have to use 2 pointers. Okay, so let's take a look at how we could do this with 2 pointers. Okay, so let's say we put our previous over here and our current over here, and I'll say our target is, again, it's 6. Now we iterate over this list by 2's. So current is going to come here and previous is going to come here. We're going to check, is the current equal the target? It does. And so all we have to do now is just go ahead and break this pointer over here at 2 and set it to the current.next. And then we can go ahead and increment our current. And then we continue on with the iteration. We go ahead and move current over here. We move previous over here. Does current equal 6? It does not. We move current over here, previous over here. Does current equal 6? It does not. We move current over here and previous over here, and we check, does current equal 6? It does. And so what do we want to do? We want to go ahead and take the previous dot next, this pointer over here, and set it to current dot next, which is null. We'll set that to null. And now we have gone through the entire list, and the nodes that we have left are 1, 2, 3, 4, 5, and 6. Okay, so 2 pointers works, but there is an edge case here. There is an edge case. Okay, and let's go ahead and see if we can move this. Let me go ahead and grab my pointer tool here. We'll go ahead and move this over here. And let's take a look at if we have a list here, 1, 2, 6, 3, 4, 5, and 6. Okay, and let's say our target value is 1. It's at the head. But if we set our previous here and our current here, and we're checking here on current, there's no way to check what was behind it. Okay, and so this would not equal 6. We would move the current, we'd move the previous, and we would totally miss the target node that we're trying to remove. And so a way we can get around this is, and this is a good method to know anytime you're dealing with any sort of linked list that deals with addition or subtraction, removal or addition of a linked list, is you want to use a method where you use a dummy node. Okay, we're going to create a node and just set it to -1 before the head and point it to the head. Okay, and then what we're going to do is we're going to set our previous node actually one step behind the head on a dummy node. We'll instantiate a whole new node, and then we will set our previous to that dummy node, and the next will point to the head. Okay, so this will now be our current, and now it follows the same pattern as it did up here for how we traversed it on the top example. And so again, if current is 1, this previous will break over here. It'll point to current.next, we'll increment current, and we'll go traverse through the whole list. When we get to the end and everything's removed, then all we have is we have a variable, we can call it dummy, and it's pointing to that dummy head. Even though the previous is gone all the way to the end, current will be over here, previous will be here, we still have this pointer pointing to this dummy head. Okay, and then all we do is return dummy.next, and for this list right over here, the final list should look like 2, 6, 3, 4, 5, and 6 if we're removing 1. Okay, and then all we're going to do is return dummy.next, which will be pointing to this 2 node right there. Okay, it'll be pointing to the head node, the new head, and that'll return that list. All right, so let's go ahead and code this up. So what we want to do is first we want to create that dummy node. So we can say let dummy equals new list node, and we'll just set it to -1. And then we're going to set dummy.next to our head node. And then we have 2 pointers. We're going to have a previous, so we can say let prev equals dummy, and let cur equals head. Okay, and now we just want to traverse through this list, which means we can just say while current is true. We want to say if current.val equals val, what do we want to do? We want to set our previous.next to our current.next, and then we want to increment our current. Okay, else what do we want to do? Else we want to increment our previous and then increment our current. Okay, and then at the end of all of this, we just want to return dummy.next. Okay, let's go ahead and run that. And we have success. And so that is Leetcode number 203. Now, before we go, let's just take a look at time and space complexity. So, what is our time complexity here? Well, how many times are we going over this list? We're only going over it once. We're iterating over it once, and we're just dynamically removing the duplicates. We're not creating a new list. We're not pushing it into an array and then pulling those numbers out. We're just iterating over the list once and just taking out the duplicates as we iterate over the list. So our time complexity here is going to be O of n. Okay, and what about space? Well, the only new space we're creating is this dummy here. Besides, and then we're creating some pointers, but we're not generating any new space relative to the size of the input. And so let me move this 1 here so it's an S. So our space is actually going to be constant. Okay, we'll have constant space. So linear time, constant space, which is not bad, which is pretty good. Okay, so that is Leetcode number 203, remove linked list. Hope you enjoyed it, and I will see you on the next one.